All right, so here's a video, pre-calc video over section 7, which is absolute value functions. So our objectives today, we want to analyze absolute value functions to determine key features of the graph. We want to model and solve mathematical and real-world problems with absolute value functions. So before we talk about absolute value, I want to talk about what absolute value represents and what it means. So I want you to write at the top, absolute value, so absolute value means distance from zero, okay? Distance from zero. And one of the key things that we know about the word distance, which is kind of what the idea of absolute value is that distance is always positive, okay? Always positive. And you guys probably remember what absolute value is. It's when and here's a graph of what that looks like. If I have, this is my parent function, f of x is equal to the absolute value of x. So no matter what I plug in for x, okay, it's always going to be positive, all right? So, and that's where you get these values. So if you plug in, if you take the absolute value of -2, okay, you get 2. Take the absolute value of -1, okay, you just take whatever that value is and you make it positive and you get 1. Okay, absolute value of 0 is 0, and then absolute value of a positive number is 1 or is positive, and absolute value of 2 is 2. Okay, so that's where you get this V-shaped graph. Okay, no matter what you plug in, all right, you get a you get a positive value. All right. So what we want to do is we want to talk about graphing these things. How do we shift them? How do we move them around? How do we make them steep? How do we make them thin? All that kind of stuff. So what we do know about the absolute value function is that the domain, you can plug in any x value, but the range, the y values, are greater than 0 or equal to 0. Okay? And so if we take a look down here, we have the standard form of an absolute value function is here. Okay? F of x is equal to a times the absolute value of x minus h plus k, where h of k is the vertex. Now that vertex, hk, is this point right here, wherever you have that point on the absolute value, okay? If your number out front, okay, is positive, then it opens up, okay? If that number is negative, then it opens down, okay? If you take that number a and you were to, say, is that number a large number, is that number larger than 1, then you get what's called a horizontal compression, which means you make it thin. Okay? And then if your number is actually less than 1, okay, then you get a horizontal stretch. Okay? So here's your parent function in blue. Okay? Here's this parent function in blue. This is the function f of x is equal to, what is that, absolute value of x, okay, that's your parent function. Notice how the slope of this line here is positive 1, the slope is negative 1. That's how I know it's a parent function, okay? But what they've done is we've manipulated it a little bit, okay? We've changed the vertex to the point -1. So the vertex is the point -1 comma -2, okay? And that's that point right here, -1, -2. All right, so if you see an absolute value function, all right, of this form here, all right, then you can move that point over as necessary. And then you have this value of 2 out here. Notice what happens to the slope of this line. The slope of this line becomes 2 over 1, up 2 over 1. Okay, so that can kind of help you. All right, this will actually be the slope of that line, okay? And that's where it means like where if it's larger, you get that compression, and that means that it gets thinner, okay? But if you had like a number, say like, let's say you had 1/2 out here, then it would be wider, okay? So that's that. All right. Okay, let's take a look at the next page. You have this function here, f of x is equal to the absolute value of x minus 4 plus 3. So notice how the slope of the line is 1 and -1, okay, for your absolute value. Notice that there's a 1 out here. There is no number, so there is a 1, okay? However, you do have a translation here, okay? And what happens is your vertex, all right, is right here. And that's at the point 4, 3. Okay, so your vertex is at the point 4, 3. Notice the numbers in this function. If you subtract that 4, okay, that moves it over to the right 4 units, and then you move it up 3. Okay? So you can figure out where these graphs are based on, the numbers in the function. Okay? Okay, then it says find the domain and range of the function. Well, the domain, okay, and here's the graph of that. Domain is from -infinity to +infinity. Okay, the domain goes from -infinity to +infinity, so it's all real numbers. And then the range, and the thing of it is that this graph has been shifted up 3 units. All right, so all of a sudden the range of this function starts at 3 and goes to +infinity. All right, and so that's what we're looking for. And so we know that f of x is greater than or equal to 3. The domain goes from -infinity to +infinity, and that's our answer. Okay? All right, let's take a look at the next one. All right, so a translation, okay, is just when you manipulate the vertex. Okay, here's your parent function. Okay, this means we moved it 3 units to the right and 2 units up. So 3 units to the right, 2 units up. Okay, so 3 and 2. Notice these numbers of 3 and +2. All right? A reflection, dilation, and translation of the parent function. So what this did, the -3, okay, so this -3 here, this reflected it over the x-axis, reflected over x-axis, and made it thinner, Okay? The -2 shifted down 2 units. So shift down 2 units. Okay? Sorry, it's kind of messy. All right? But because, and because the 3 is negative, that's what reflected it over the x-axis. Actually having the value of 3 made it thinner, okay? And then the -2 shifted it down 2 units. All right? All right, so then it says, write the equation, okay, for the function graphed on the right. So they have this value here. We just pretty much need to figure out what that value for a is. All right? Notice that you have this +1, which means you went to the left 1, and then you added 3, so you moved that value up 3. Okay? So you move to the left 1, up 3. All right, that's your translation. But then, notice what happens. Your graph opens down. So what do we have to say about A? It has to be positive or negative. It has to be negative. If this graph is opening down, then A has to be negative. Okay? And then let's think about the slope of this line. Okay, if I go down 2 over 1, I get the next point. Down 2 over 1, down 2 over 1. So my value for A is -2. Okay, the negative part flips it over the x-axis, and the 2 part makes it a little bit thinner. Okay, it gives you a slope of 2. All right, so if we wanted to write this function, we would say f of x is equal to -2 times the absolute value of x plus 1, and then plus 3. And that's what you have here. Okay? All right, let's take a look at the next one. Okay, so then it says, select the graph of f of x. It's kind of a weird graph. Okay, so first things first. All right, I have a plus 2, which means it's been shifted over 2 units and then down 1 unit. Okay, so they all have that vertex at -2, -1. Okay, except for this one. This one has -2, +1. So this one we can cancel out. All right, and then, so if you already get rid of this one, okay, it's between these two. Notice that the leading coefficient, that -0.05, or 0.5, is negative. So because it's negative, it's going to open down. All right, so you can get rid of this one as well. So this is your answer. Okay? All right, so you have that parent function. Okay? You have that value here. And it says, given the function f of x is equal to 6 times the quantity absolute value of x minus 2 plus 3, for what values of x is f of x equal to 39? So here's what you have. This is asking if you, what is the value of x when y is 39? So y equals 39, okay? And there's a couple different ways to do this. Let's look at a graph. Let's go ahead, let's go to Desmos, and I want you guys to graph this function here, f of x equals 6 times the absolute value of x minus 2 plus 3, and then I want you to graph f of x equals 39. Okay, I want you to graph both of those. I'm going to go pause this and do that real quick. All right, so here's the graph of this function, okay? Here's 6 times the absolute value of x minus 2, and then plus 3. And then here's the line y equals 39. Now what we're trying to solve for, okay, we want to find the x values when the y value is 39. So what I've done is I've plotted those intersection points, and I find that x is equal to -4 and x is equal to 8. Okay? Now what I'm going to do is I'm going to show you guys how to do this algebraically as well. You can do it graphically, but you should be able to do both. What I'm going to do is I'm going to set 39 equal to 6 times the absolute value of x minus 2 and then plus 3. And I'm going to solve this for x. Okay, what I'm going to do is I'm going to subtract 3 from both sides. That's the first thing I'm going to do. And I get 36 is equal to 6 times the absolute value of x minus 2. Okay, and then I'm going to divide both sides by 6. So then I get that 6 is equal to the absolute value of x minus 2. Now, getting rid of the absolute value symbols at this point is kind of tricky. All right? What you need to do, okay, to get rid of the absolute value symbol is this. You take 6 is equal to x minus 2, okay, and you take -6 is equal to x minus 2. All right? Now, here's why. If I take the absolute value of some number x and I get 6 out of it, what could x equal? X could be both +6. All right, take the absolute value of +6, you get 6. Or x could equal -6. Because you could take the absolute value of -6 and you're still going to get 6. So when you get rid of the absolute value symbol, whatever the absolute value is equal to, you have to set it to the +1 and to the -1. All right? And that's why I did that here, okay? Because I just have the absolute value symbol. I set it equal to 6, and then I set it equal to -6. Now I can just solve this, and I'm going to add 2 to both sides, so I get that x is equal to 8, which is one of those values we wrote down. Okay, and then the other one, if I add 2 to both sides here, I get that negative 4 is equal to x, which was the other value that we got here and here. Okay, so graphically and algebraically, we need to be able to do it. All right? So the answer to our problems, right, positive 8, negative 4, yeah. And this is the answer to all of our problems. Personal problems, relationship problems, any problem that we have, we can be answered by solving absolute value functions.